Hi guys, welcome to another Learn Electronics Repair video. I have some PCBs here from PCBWay who are kindly sponsoring this video. These are for one of the shared projects which is on their website. I'll give you the link in the description to this video. This project is for a MilliOhm or micro-ohm meter. So I thought it'd be interesting to build one of these, MilliOhm meter by Electrolab. I didn't design this, Electrolab uploaded this as a shared project and they get a commission from the sale of all the PCBs. Just the same as I uploaded our short finder project, and I have received some commission. Thank you to you guys who ordered the PCBs, and you yourselves can upload your own projects. So I'll show you the project on PCBWay and on Electrolab's YouTube channel, and then let's build it and see how well this actually works. Here we have the PCBWay.com website. You can order your PCBs from here. And you can also browse around in the shared projects. And here you'll find thousands of projects which you can build and order the PCBs from PCBWay. The one I'm interested in is this project. So this is a project on PCBWay. It has very high ratings. This is being rated by other members on here. And there's a link here to the original video on YouTube. So we can go to the YouTube video, and from here we can find in the description all the various files. So on here we have the link to all the files which I've downloaded. So I'll show you what I actually have, and then we can start putting this together. Amongst the downloaded files, I had a zip which contains, it looks like, all the layout and Gerber files for the actual PCB, although I ordered them ready-made, but it would appear from this you can probably make your own PCBs. We have the schematic. So the schematic is quite simple. It uses two Op Amp chips, a Mosfet, TL431 voltage reference, and a lot of common parts, to be honest. I had almost all the parts for this already here. These diodes are 3.3 volt Zener diodes, 1 watt, which I have. I don't have the correct Mosfet. I have ordered, but it's not here yet. And I don't have the correct Op Amps OP07. I have ordered, but they're not here yet. But I'm going to try fit some sockets and see if we can use some compatible Op Amps to see if it works until the other ones actually arrive. And again, I'll see if I can find a different FET. I think IRF540 is a fairly common thing, and we can probably find something we can use instead of that. But if not, the other ones will arrive eventually. It has plus and minus voltage supply. It doesn't specify on here what the supply is, but I'm hoping that information is in the YouTube video. And now we can have a look at the bill of materials. So let's see what we need to put all this together. And there we go. So we have common parts: 100 nanofarad capacitors, 1 microfarad, lots of common resistors. So the capacitors I have, resistors I have, TL431 I have, and you can salvage these from just about any switch mode power adapter, switch mode power supply, ATX power supply, but you can buy something cheap. Yeah, MOSFET I don't have. Diodes quite common. If you have some Zener diodes, you may have to buy these. So really the only things I had to buy was the actual meter, which I'll show you in a moment. The Op Amps I've ordered and the FET I've ordered which haven't arrived yet, and then the banana or 4mm sockets to actually attach the probes to the tester. This is the original video. It's not in English, but we can put the subtitles on, and we can select, it's in Portuguese at the moment, auto translate to whatever language we like. This is an English channel, so we'll choose English, and we can now basically understand what he is saying to us. So I'll have a quick look. I'm just going to mute this guy one moment. There you go. So I'm not talking over him anymore. I will let Electrolab know I'm going to feature this on my channel. I hope they'll be happy with that. Some promotion for them. You can see the channel name there if you want to go and have a look at these guys. The sockets he's showing here, I've ordered some sockets, so I had to buy those. And let me have a quick look to see if I can figure out anything else we might need. Just flicking through the video, he shows us the PCBs. He shows us the assembled PCB, the schematic we already have. The assembled PCB we can see here. He also, the power supply plus or minus 15, he's saying. I'm sure we can find something to use there. He's shown us how to put it together on the bench. And he's tested it, and he's also shown us a suitable box. So it's just a power switch, the meter, and these are the banana connectors I ordered. I'm sure I can find the switch, so I think I have everything we need to build this. Let's see if we can find equivalents for the op amp and the MOSFET we don't have. So we can do a quick Google search for OP07 equivalent. I found some links here. I did have a quick look, and this seems to tell me what I want to know. So this shows the pinout, and it gives some equivalents. UA741, that's a very common one. TL081, that's also another very common one. So let me have a quick look to see if I have either of these op amps available. Yes, I have some UA. I keep all the chips starting with UA in here, and I have some UA741. So we can use these. I'll put sockets on the board anyway, and if we have to change them, then that's fair enough when the OP07s turn up. So we have two of those. I already have a load of banana sockets here, so I can use some of these. We'll have a couple of red ones and a couple of black ones. I just order these like 10 at a time from AliExpress and keep some in stock. And again, I have pumps to go with them. But I'm going to try something else for the actual Kelvin probes. Kelvin probes, or the 4-meter probes, can be a bit expensive. So I was looking for a cheap alternative, and what I've come up with is these. So these are actually SMD meter probes, SMD tweezer type, yeah. But basically, you have two connections coming out of two metal fingers here. And I'm thinking that either we can hold them together and use them as a Kelvin probe, or I can even solder them together at the bottom, and then effectively I've got a Kelvin probe. So I've ordered a couple of those off AliExpress. They were about €2 each, so they were much cheaper than buying Kelvin probes. So we'll use those as probes. Now let's have a look to see if we can find a suitable MOSFET. The MOSFET we require is IRF540. I don't have any of these. I do have some IRF640, which are obviously salvaged from something. It may be that this is a similar MOSFET. I'll have to look at the datasheet. Basically, the MOSFET on here, I believe, is used just as a constant current source, and I doubt it injects a lot of current. It might maybe 50 or 100 milliamps, I'm not sure. We'd have to look at the video in more detail. But I imagine probably any MOSFET, as long as it's the right type, N-type or P-type, depending on the datasheet, and with a similar power rating and current rating, would probably work. Let's have a quick look at the IRF540 datasheet and see if this is any way compatible or usable in this instance. And if not, I'll have a look to see what else I have. It's an N-channel MOSFET, 100 volts, 23 amps, RDS on 77 milliohms, gate drain source. So that's what it is. It's 100 volts, 23 amps, continuous 16 amps. But we need nothing like this to actually work in our MilliOhm meter. Let's have a chance of the IRF640 is something I can use. Well, it's N channel again. 200 volt 16 amp, slightly higher on resistance might affect the way it works. Gate drain source. Let's check on the other one. Gate drain source. So it's the same pin out. So I think I'll just try this. Again, I have ordered the correct ones, but we can give it a go and see whether this different RDS has any effect on the performance in this circuit. Okay, so that's kind of possibly solved that one. That's some very nice PCBs. I have 5 of them, but we'll use 1 to build this project. The other thing I had to buy was the meter. So the meter is I don't know if you can see it very well, it's a 5-digit meter. It was a little bit hard to find on AliExpress. I'll have to shine the torch so you can see what it is. Yeah, you see it's 5-digit meter. This is the one that he basically says to use. You have to watch the video. He gives a part number. I couldn't find it, but it was a 3 volt meter basically. I hope I have the right one. We'll try it. Yeah, 30 volt meter, sorry, that's what he said it was. So we'll see. So we have that. That was about €6 or €7. That was the most expensive part. Let's get together all the other bits we need, and then we should be able to start putting this together. The capacitors C1 to C7, if we look at this video, we can see they are ceramic capacitors. So I'll find a handful of ceramic capacitors, new or used, I'm sure I will have. The other one is an electrolytic, so we have that. We have normal quarter watt resistors. There's one high wattage resistor here which I hadn't noticed, so I'll see if I have something suitable to put there. And we have a couple of little trimmer pots. So if you look on the information here, the trimmer pots, we have a 10k and a 100k. I'm sure I have some of those. And the capacitors are not going to be a problem, or the resistors. So let me get these bits together and then we'll figure out what else we need to complete this. 100 nanofarad capacitors. I have a whole bag here, some salvage, some new. We can see what's in here. So yeah, it looks like I've probably got enough new ones to do it. 5, 6, 7. Yeah, so we can use that. So that's the 100 nanofarad capacitors. I'm not sure what this is doing in here because it's not 100. That's actually 100 microfarad. Ends up in the wrong place somehow. But I have quite a lot of these sort of salvage type capacitors. I'm sure we could use salvage ones just as well as we could use new ones. I suspect these are just effectively decoupling capacitors. Okay, so we have the capacitors, we just need the electrolytic, and then we have all the capacitors. The other capacitor, I have a whole box here. So I have some 1 microfarad 50 volts. He doesn't specify the voltage. Again, these are salvaged ones, but I'm sure they're okay. We can check that with a capacitance meter before we use it, just to make sure. So let's have one of these attractive looking orange ones. We can just check it first, but I'm pretty sure that will be good. I don't think it's necessary to read the ESR on this. It's not being used as in a high frequency switching circuit, so let's just check it's a good capacitor. It's always worth doing this with salvage bits because you never know. Yeah, 1. So we have that. I'll put this one back in the box where it came from. It's obviously escaped from somewhere. This came out with the 100. Got out with the 100 nanofarad gel. I'll put that back in its box. So that's all the capacitors. Now let's get together the resistors we need. So we need some 1k, 100k, 10k and 22k. And this one, I think the 10 ohm is in actual fact the higher power resistor. I could watch the video, you may tell us what it is, but I'm pretty sure I can find something hefty enough to put in there. So I'll get these together. These will probably all be new, and I suspect the power resistor will be something I've salvaged from somewhere. I'll see what I can find. So resistors I keep in drawers like this, 4 values per drawer. I bought a lot of these off AliExpress a long time ago, and probably got some from Maplins when they were practically giving away in packs as well. So we want 5 of the 1k and several of the others. they're not very exciting really, resistors, so we'll just skip that bit of video. I'll get together what we need and then we'll look at some of the more interesting components. Yeah, here are our resistors, a couple of 22Ks, a couple of 100Ks. These are 5 100Ks, these are a couple of 10Ks, 22Ks, 1Ks, so we have those. So it's just this 10 ohm resistor, we need to find something. Have some salvage ones, these are 10 to 8 to 2, they're 15s, it just depends what's in the box really. 4.7, oh there we go, 10 ohm, yeah, 10 or 0, that's a 5 watt, I'm sure that is big enough. It won't fit directly on the PCB, but we can manage. Oh, something in here that might do, something longer. Let's see what it is. Let's see what it is in this bag of bits. No, it's an 82 ohm, so that's no use. And what are these? Oh, these are 10 ohm as well, and these will fit, I think. Yeah, I think they'll actually fit. So I might use one of them, or I might use the other one that I found, depending on. I'll probably put the smaller one in first and see how hot it gets. Yeah, that's probably the best bet with that. And if it's too hot, I'll put the other one in. What I'm actually, I've just spotted in here, by the way, is some ferrite beads. I'll keep them on one side. They're useful things to keep those. Yeah, we need the variable resistors, 10K, 100K, so we can have a dig around for those. And these diodes, I looked it up, these are 3.3 volt Zener diodes, 1 watt, I'll have some of those. Again, I bought a whole pack of diodes basically from AliExpress. I looked for a pack of Zener diodes, 1 watt, and I just bought 10 of a whole range of values. Very cheap again, that's the best way to buy components for projects, to be honest, if you want to save money. And that's basically also how I got these. So these are trimmer pots, various values again. Once again, I bought some, I got a load of them as an amateur radio rally, and then I also bought a load off AliExpress again as packs. Now he has the vertical ones, and I think I have some in here that will do. So let's see what we have. Yeah, there's one there. I think a couple of these will actually fit into the PCB. We can have a look. His are in a straight line. No, they're a little bit wide to fit in the legs. We've got something that will actually fit in. Let's see what we have if something will actually fit directly. If not, I can modify them slightly to get them to fit. Yeah, I think I'll just have to effectively, yeah, modify these. It's only, well, in this respect, it's only single-sided. There's nothing coming through there, so I'm sure I can actually tag them on this side of the board. So we have the Diodes 1M4742A, which I will just look this one up. This one's common, so those I've got. It's a good job I looked because it's not a 3.3 volt Zener. 4742A is a 12 volt Zener. Again, I'll have them. It's a 12 volt Zener, and I'm pretty sure these are effectively 1 watt Zener diodes. I'm sure it'll say that somewhere up near the top of the thing. Yeah, 1 watt. Okay, let's find some of those. Much the same, I bought a whole pack off AliExpress at some time. Usually if I'm ordering from AliExpress, I have a quick look for like component packs at the same time. Now if I find something useful and they're cheap, I'll just buy them and just keep them in stock. They're worth having. So if we have a look through here, I'm sure we'll find some 12 volt Zener diodes. They don't seem to be in any particular order. 3.3, 9.1, 8.2. But I keep them well enough organised to find what I want. Yeah, 10, 12. Okay, so there's our 12 volt Zeners, and we want 5 of these. I'll probably add these back to the list. If I've used half of them, I'll probably think, okay, I'll just order more of that value. I might need them again in future. So that's the Zener diodes. Now we need 1M4007. Yep, got those ones. Got to keep these in stock, guys. You can buy these and then they'll use them to replace everything from 1M4001 to 1M4007. You don't have to keep any of the other ones in stock. So this is worth buying 100, probably cost you like €1, and you've got enough to last you for ages there, yeah? Just remember to order some more when they start getting low. Not when you need them because you didn't order any. Okay, let's have a last look to see if there's anything else we need. No, I think we have everything on the list, so we can start putting our project together. The way I normally do this, and to be quite honest, the way everybody should normally do this, this is common knowledge if you're building projects, is to start with the components that are flattish to the board first, which is usually the resistors. So let's have a go putting some resistors on our board first. So we have, I'm just looking at my list, we have 5 of the 1K. So we have 1K resistors, and we know which numbers they are from that Excel. So we have R1, R3, 4 and 5. So let's see if we can find where these go on here. And it's also good practice to put all the resistors in the same way round. When I mean the same way round, so that the actual colour codes read in the same direction, it's just good practice. Or it's being OCD, yeah, whichever you think is actually correct. So I'll get and insert all these resistors. I'll get them soldered into the PCB. In fact, I'll show you that. Let's see how nice these PCBs are to actually work with. I normally do this by inserting all the resistors of the same value at a time. So this is all the 1K resistors. So I've put them in the board. It's out of focus. I can't hold it low enough down. So once I put all the ones of one value in, I then solder them and go on to the next value. So we'll stick these in and let's see just how nice these PCBWay PCBs are to work with. So get a bit of solder. I won't take any flux, just solder. Let's see how well it solders. Yeah, that solder's nice actually. That solder's nice. Let's get the rest of them on and then see whether it's effectively drawing through the PCB holes, the drill holes. Let's see. So it should draw the solder in. Yep, so far so good. There's just one more to do. And then we can just make sure they're sitting flat and then cut the legs off. So yeah, they're all sitting nice and flat on the PCB. So we'll chop the legs off these and then let's have a look to see how well they actually soldered in. My favourite technique you've just seen is to solder them first, chop off the legs and then just touch once again on each soldered joint just to make it kind of like cover over where I cut the leg, if you know what I mean. Just my chosen method. Interesting to know what you guys prefer, or if you really would like to put forward a reasoned argument as to why one way is better than another. Yeah, let's get in there, guys. So one or two people commented about me deleting comments, by the way. I never delete comments apart from the ones that appear in the first 30 minutes, which are porn links. And I've got nothing against porn, it's just not really the time and the place, you know. On the electronics repair channel, I don't see why they feel that electronics repair people are obviously all wanting to watch porn, yeah. Even if some of us do watch it, I mean, it doesn't, you know. I don't know, I don't get it. But anyway, apart from those links, I don't delete anything, but YouTube does. YouTube deletes comments and never even gives me an option. So in my feed I can see the comments there, I can actually read it, but when I go to the channel it's gone and I can't get it back. So if you guys find I'm deleting your comments, I'm not, guys. If you're the guys who are posting the porn links, just post them somewhere else, please. Okay, right, let's see. We have those resistors in. You can see I've put them all the same way round, so reading top to bottom, reading left to right. Comments below, guys. Is that being OCD or is that good practice? While you're thinking about that, let's put the rest of the resistors in. Okay, there's all our resistors soldered, as I say, all in the same direction of reading the codes, and I'm interested to know what you guys think about that, as I mentioned before. I actually think I am a bit OCD. I mean, I will say this, when I was at school and I was a kid, right, I was what was known as a right little sod. Yeah, as a right little sod, me. If I was at school now, I tell you now, if I was at school now, I'd have letters after my name, yeah. And I don't mean qualifications or honours either, yeah. I mean, what they call right little sods these days. I don't know why all these ADHD, whatever, so they're just right little sods, yeah, that's all they are. And I was, and occasionally we get the cane or the pump across the arse, yeah, the plimsoll across. And you know what? Actually, it calmed us down mostly. So you can talk about that as well. But being beat around a bit by the teachers at school certainly didn't turn me into a twisted and deranged individual. Yeah. So I'll just be OCD about my resistors all in the same direction. And this bothers me slightly because the 10k resistors are 4-band codes and all the rest are 3-band codes, but I didn't have any 3-band code 10k resistors. And the other thing that slightly bothers me is I forgot to take one of the parts that we need, which is the TL431. So let's get that now, yeah? So these are my TL431s. This is my TL431 tester, by the way, which I built a good while ago, and I'll actually link that video so you can have a look if you never built it. And these are my TL431s, and you can see they're all salvage. I've never bought one of these things in my life, but every power supply you dismantle for whatever reason, you will find one of these, and it's almost all of them. And they're not all marked TL431. This, if you can see, it is a KIA 431, but they're all equivalent, yeah, so we'll use that one in ours. Okay, so that's the last bit, I think. Put this away, and then let's get the capacitors fitted. That's all the capacitors fitted except for the electrolytic. It doesn't matter which way these go in, although me being me, I've got all the ones with the writing face in the same direction. You learned a bit about me today, guys. But this one is important, yeah. Negative to the negative. It's marked plus on one end of it. Don't put it in the wrong way around. If you do put one in the wrong way around, a bit like winding the teacher up to the point where you've got the cane, you'll know, because if you put one the wrong way around, when it explodes, you'll kind of like remember not to put one in the wrong way around next time. Yeah. Okay, another day, another t-shirt, by the way. Cheers PCBWay for the t-shirt, thank you. And we can continue with this, so we're getting somewhere. We just need to put the diodes in next, I think. We have D2, which is 1N4007. D2 is here, so again it's marked nicely. There's a stripe on the component, there's a stripe on the PCB, so this can go in here, and we can just get it nice and flat onto the board. There we go. And then we have the 4 Zener diodes. We'll solder this one first, and then we can get on with the others. We have now 5 more diodes, and they're all the same, so they are the Zener diodes, so that we have them here. Okay, and we can just look for diodes. These are all the remainder of them, so I'm actually going to bend this with the pliers. The other one didn't fit in very well. It's actually probably better to bend them this way anyway, because it doesn't put any stress on where the lead comes out of the encapsulation. Yeah, so for those of you who are going to tell me off about that in the comments, you still can't, because I was doing it, but I've also corrected myself. Yeah, so let's get the rest of these diodes on our board. We are definitely getting somewhere now. Here's our 10 ohm power resistor, so we can again use the long nose pliers to bend the legs, and I'm hoping these are going to be just long enough to actually reach. But if I get it soldered to this side, it should be okay. Let's see. I think we can probably get the leads to go through the holes actually with a little bit of effort. It almost wants to reach. A little bit of persuasion. There we go. So yeah, I've actually got it to go in. I mean, on this end, the track only is on one side anyway, and on the other end, it's actually the track is only on the other side anyway. So what I can do with this one, just to make sure it does solder, you can get from this side. There we go. And we can go to this side. And I'll probably just put a bit of solder on there as well. Okay, so that's on. What else do we have? We have sockets, I think we'll use for the chips. Again, I bought all these. I bought one big bag full from Mapley's when they were selling them cheap before they closed down, and I think I bought some more from AliExpress as well. I'm pretty sure I have got in here some 8-way sockets, but if not, I can just take one of these and just effectively cut it off at the length I want and use it. But I probably will have in the bottom of here somewhere some 8-way. Yeah, I have. So we can use these. What I will do, I didn't have many of these, so again I just add them onto my list of things so that next time I'm ordering from AliExpress, I'll probably get a bag full of 20 or 50 or whatever for not very much money. So that's what I normally do, and then I don't have to worry about not having any the next time I want some. Just try and hold this in place and solder it this way. It might be the easiest way. Thing with doing this is not to have your finger on the actual leg that you're soldering on the other side, basically. If you have, you'll soon know about it. Yeah, that's in. That's in, and it's nice and flat, so we can just get one this corner, and then we can just make sure it is actually sitting flat in our board. I was on the hot one. That's in. That's it. Okay, solder this one, and then same with the other. Okay, so we have the two sockets on there, both the right way round with a little notch at this end to match the little notch on the PCB. Not much to fit now, so we'll get the variable resistors on next. These we have two of them, marked 103 and 104. So the first two numbers are the value, and the third one is the number of zeros to follow the value. So 10 and 3 zeros is 10,000 or 10k, and this one 10 and 4 zeros is 100,000 or 100k. So the 10k is RV2, so the 100k, this one is RV1. Now these are different ones that I originally picked up, but these actually fit into the PCB. And I think in actual fact I can probably bend this leg in and get it to actually sit. Yeah, but I can't get that middle pin to reach like that. So if I fit a little bit of solder on there, I mean, actually, you know, having said that, I probably can get it to reach, but it will sit at a bit of an angle. Push this in. Yeah, can you see it? It reaches. It reaches. Yeah. We'll do it that way. That's going to be easy. So I'll push down on it and solder it. It's not going through the hole, but the hole again is not on the other side. There's no tracks. On the top is a track, and anyway they plate it through holes, so it would still work if there was tracks both sides. So let's try it. We'll go for the middle pin first. Yeah, and I'll kind of like push, raise this up a little bit, and I'll push down on it and we'll get it to actually there. It's in, yeah. So that one is fitted, and it can't hit this resistor. Look, it's quite raised up, and it's also very solid. So let's do the same with RV2, which is going to be the 100k, sorry, the 10k resistor. Okay, once again it's solid. With this one, the middle pin actually comes through to the other side, but we can easily check if we have a connection there. If I just get my meter, we'll just measure from one of the ends to the middle. This is what we have on resistance range. And we're reading like 40k, yeah. So to the other end should read about 60, giving us a total of 100k. Let's have a look. Well, 40 and 40. There's obviously other things in circuit. So to prove it's working, we can adjust the potentiometer to one end and then measure the resistance again. So we'll just, I mean, it's somewhere near the middle, so it's probably okay. We'll turn it to one end, and we should now have basically 0 to that end. Yeah, okay, so we definitely have a connection. So that's that done. What else do we have? We have the TL431, which is going to be a bit close to here, but I don't think it'll be a problem. So here's our TL431. I could test it, it's a pull, but I'm going to just be lazy today and put it in. I did build a TL431 tester, and this should now fit in. If you're interested in the TL431 tester, and why not, yeah, I'll link it in the description from this video so you can actually have a look to see how to build one of those. So that's in place, we're in there, we see the shape of it on the silk screen, so we know it's the right way round. So let's just solder our TL431 to here. Okay, that's nicely soldered. It's soldered through the holes. These PCBs are really nice to work with, really nice PCBs. Now we have the MOSFET. These are salvaged ones again. I will just check this. I'm still feeling lazy, but it's a lot, well, say a lot, it's a minute or two quicker than testing the TL431. Plus, to be quite honest, I think I've ever found a faulty TL431. They're very reliable. I'm not saying they don't fail, but I've not found one. Have you guys ever found a TL431 faulty? Any of you? Just let me know. Okay, so on the silk screen, this sort of striped area, that means heat sink. So this should have a heat sink on it. I've had a quick look at the original video, and he has not a very large heat sink on. Probably something a bit like this. It's probably a bit bigger than this, the one he has. This is designed to fit into a PCB, but I'm not going to use that. I'm going to actually mount it effectively upside down for now. I mean, that's not perfect because it's not effectively connecting to the entire tab on here. Let's see if we can actually, oh yeah, no, we can go that way with it. If I take this pin off here, that should come off or break off, then I should get this to fit. Yeah, and we'll try that for the heatsink. Yeah, it's broke off, that's fine, it's broke off flush, that'll do. So we can put our MOSFET on here. I'm sure I can find a small bolt here. It looks like it's threaded in there, a little bolt, and then we can put this on. Well, I might as well put a little bit of heatsink compound as well. This stuff will be fine. I've had this for years. Or you could use a bit of the stuff that comes with CPUs. I'm pretty sure for what we want, a bit of this stuff, and it will be fine to put in there. Yeah, that'll do. Nasty stuff. Pigeon shit we called this, by the way. In the 80s. It's probably still called that in some places. So we can put that on there, and I think this should fit into it quite nicely actually. Okay, the original screw I tried didn't fit very well, but that one's fine, so we have that bolted on, and this should fit quite nicely onto here. Yeah, I might have to just clean a little bit of solder off the legs first, but is it going to go in? It's going to go in. Heat sinks are one of these things you should really always salvage if you're stripping stuff apart. You might not seem the most obvious thing, but heat sinks are definitely worth having. I'll put a little bit of flux on this, it's just not soldering very well. Maybe the legs of the MOSFET are a little bit grubby. Yeah, that's got it nicely. So, what do we have? Well, I think we have everything, all we need now. This is the constant current out, so this goes to marked plus and minus, so this goes to the current out on the Kelvin probes, that's one each of these. This is the sense, again marked plus and minus, so this is the other pair of these. But what we then have, I was going to try using these as Kelvin probes. Now These have a red and a black on here, but actually you want the two reds to connect together and the two blacks to connect together. So really we want to change one of these on each, swap them over, so one of them has two red connectors and the other has two black connectors. I can probably do that actually by cutting one of them off here, then putting a bit of heat shrink and swapping them over. It's not necessary from an electrical point of view, it's just to make sure you actually plug these in the right way round. So we'll do that. So that's those there and there. This is where the power connects in. So we need a plus and minus 15 volt supply. So for now I'm going to use, I have a dual output bench supply, so I'll do it with a bench supply to test it. But to use this we need a plus and minus 15 volt supply, so that's something we're going to have to build or find. We might be able to just buy something offline, but I think it'd make an interesting little project as well, so we can look at how we're going to do that, most likely on a separate video. For now we need to test this. The test meter connects to here, so this is our test meter. On the input, V in plus and minus, and then we have the power to this as well. I think this might need a separate power. I'll check on the spec. There was two connectors on, so it's quite likely one connector is for power and one is the input to the meter. So we can now plug our op amp chips in and we can test this on the bench first to see if it's working, and in the meantime at the weekend, tomorrow Sunday, I'll be down at the car boot sale, unless I can find a suitable enclosure to put this in. I'm thinking maybe a scrap satellite receiver or something we can build it all into. So for me it will be a couple of days before we test this, but for you guys, due to the magic of YouTube, you can go straight down the time warp and you can see it now at the click of a finger. And there we have it really. I've attached the plugs on. I mean, we can build it into an enclosure if it's working. I've modified the Kelvin probes, yeah. My idea whether these will work as Kelvin probes. So this one has two red wires on and this one has two black wires on. It doesn't matter which black goes to which black and which red goes to which red, because effectively it connects them together. So one of the reds is the current out and the other one is the sense, and then one of the blacks is a negative current out and that's the sense. So basically you connect the two together. This has become bent, it's not very rigid, I can see. I may end up soldering these together because we effectively want these things to be connected to each other, but let's try it. So we can attach our Kelvin probes first. If we can get the little plastic things out of here. So we have the black ones. We can connect the red one, which goes between obviously the two red sockets. One there. I've changed this potentiometer. This is a 10K 103. Somehow when I was putting it together I accidentally put a 104 there, 100K, but I gave it a look over before I finished and noticed, so I've changed that. I have a few more wires. So this wire here, plus and minus, is actually in fact going to the meter, and I've just realised I've actually got the wrong way round, so let me just fix that. That's another little problem. So we can tag these on the top, I think. Actually there's the minus. Okay, I need to probably refit these anyway when I put it into an enclosure, so let's just make sure we have the meter the right way round, plus and minus. So this is the display voltage, and on the little bit of information that came with AliExpress for this, where it says VM plus and minus, that's where we have the voltage. So this measures from 0 volts to 30 volts or 33 volts, but if it's reading below 4.3 volts then you get like 4 digits after the point. Once it goes above that you get 3 digits after the point, so it automatically moves the decimal point at 4.3 volts. We have another one that connects to the meter. This also requires a power supply. Power supply can be between 4.5 and 30 volts. Now our power coming into the project is going to be here. So we have ground, we have plus 15 and minus 15. So I'm going to take the same plus 15 and use it to power this device and the meter. So I'll just solder this one onto here, if we can do it. Yeah, looks like I have it. So that's the positive supply to the meter, and then the ground is going to go to ground. It says that you don't need to isolate the ground for the power supply from the ground to the meter on this one, but we can see it does say it can affect the resolution of it. So we could use a separate power supply for the meter and isolated ground, but let's try it. Let's just tag the two together, and let's have it to see how the guy on the original video also connected his up. Well, basically, as far as I can see, this is now ready to go with a plus, minus and ground. And I'm going to use my bench power supply. I have a dual bench power supply, so that can provide plus or minus 15. That'll do for now, but I'm sure I had a look actually on AliExpress and I found something we can use when we put this together permanently. I have my bench power supply set to series mode, and it's basically set to plus and minus 15, so we can just check on the cables coming from the power supply on the meter. So I have my black meter lead connected to ground on the power supply. So this is the positive supply rail and we have 15 volts, and this is the negative supply rail and we have minus 15 volts. I'll show you something I found on AliExpress we can use in the finally boxed up version, but for now let's connect the power to our project and let's see if it actually works. Well, it powers up and it does something when you connect these together. I've soldered them together now to make them more like Kelvin probes, so it changes the display, but I'm not getting any sort of sensible reading out of it. So I had a quick look at the original video trying to translate it, and I'll just show you what I know and then we can have a look how to set this up. I think this is the schematic. He's talking about this part of the circuit. I've actually just paused the video here, but basically this is the TL431 voltage reference, and all this part of the circuit is basically a constant current source. It generates 100 milliamps of current output, so we can measure the current that's flowing to see if this is working. I'm assuming that's what this potentiometer does here, is to actually set the current. Now there's a couple of ways to do it. One, we could actually measure the voltage across this 10 ohm resistor. He uses a 3 watt, by the way. I think mine is at least 3 watts, so I think it's okay. So we could measure the voltage across here. Now we can use Ohm's law to figure out what current is flowing when we have the Kelvin probes touch to each other. That's the current we inject into the device under test, and the way to do that, current I equals V over R. But there's another way I can do it as well actually, which I'll probably do to save us bothering doing any maths. The easiest way to do this without measuring the voltage drop across the 10 ohm resistor and working out the current that way is to use the current meter on the actual power supply. So at the moment on the positive supply it's supplying 20 milliamps. Now I'm pretty sure that's going into this meter because this is only connected to the positive supply. So when I touch the two probes together it goes to 150 milliamps. So we can assume, well in fact assume, we know really the other 130 milliamps is the constant current source. And if we adjust this resistor, variable resistor, the 100k, and that changes, we know exactly that's what it is. So we can put that together, you've got 150 milliamps. Now let's try to adjust this. Oh, that's 160. So if we turn this down so we get 120 there, okay, off is 20, on is 120. So we know we have 100 milliamps. Now the resolution of the display on here is only 10 milliamps, so it's going to be somewhere between 101 and 109 basically, but it's close enough. I think we know we have about 100 milliamps. I can also test our resistor, and it's not hot, it's not even warm, so that's fine. So what we now need to figure out is why the display isn't giving us any sensible reading. This should display the resistance between the 2 points, and it's just saying 10, 11. It does change, it does drop when we connect them together, so something's happening, which is a good sign, I guess. But we need to figure out now how to set this, and it might be something to do with the other potentiometer. I've paused the video again at this point, but what he's explaining is, in this kind of like, pidgin English subtitles, is that these Zener diodes, which are mounted here, are basically there to stop the input of the op amp going above plus or minus 12 if there's some high voltage on the sensor. They're just protection devices. So effectively, if there isn't a high voltage more than plus or minus 12, they're not actually doing anything. These two resistors, 10k, and these two resistors, 100k, is what sets the gain of this amplifier. So it multiplies the voltage across here by 10. And he says they're precision, they're critical. So he says preferably you need to use 1% resistors, and you need to measure the resistors to find them as close as possible to the rated value, and to balance them so the two are as close as possibly matched to each other. And I think that's why our circuit isn't working, because I just stuck any old resistors in there, which are probably 5% resistors. So this is what we need to do next. We need to take these resistors out, measure them, and then see if we can find some that are matched to each other and put those in, and then let's see if it works. Now we know basically how it works. There's a couple of things I think we need to do. The first one is to set it to 100 milliamps properly, because that apparently, well, it's using Ohm's law to effectively work out the voltage drop across the resistor we're testing, so the accuracy will depend on that. So rather than using my bench power supply, I mean, I know it's within the realms of 100 because it's on the power supply, but we'll do it better. So what we'll do is first I'll just get some crocodile clip leads, and let's measure first the resistance. I'll switch it off, so it's off. Let's measure the resistance of our 10 ohm resistor. It's only a 5%, so it's not going to be completely accurate. So let's see what we have, and then we can measure the voltage drop across it and we can work it out. So first of all, what's the actual resistance? Well, it's 9.6 according to this meter. I have a slightly more accurate one, which is the Aneng, which gives me an extra decimal point. So let's have a look at that. Well, this is saying 10.24. The question is then which one to believe. Let's measure it with the fluke, and let's go for the best of 3 then. Let's go for the best of 3 here. I don't think it's been affected in the circuit, because if you look at the circuit, there's nothing else really around here connected across it that would have any effect particularly. But let's try. So we're on ohms range on the fluke. Well, that says 11.3 that way. Oh, it reads different both ways, 10.6. So I'm not sure without actually removing it which would be the most accurate reading. Let's have a look on this one. 10.2. Well, that reads the same both ways. This is kind of the middle reading between the 3 meters, so I'm going to go with this one, 10.2. So we can work out using Ohm's law what voltage drop we should have across this to give us 100 milliamps flowing through it. V equals I times R, VIR. So the current flowing is 100 milliamps, which is an amp, so it's 0.1 of an amp, times, and the resistance is reading 10.2. So 1.02 volts across it will be 100 milliamps. I have some crocodile clippers connected to the meter, so my hands are free. We can switch this back on again, and then we can short the two probes together. The power supply is saying, well, yeah, make a good connection, 100 milliamps. This is saying 1.04, so let's adjust this till it says 1.02. I noticed on the original he was using multi-term potentiometers, which might be a bit easier to use, but 1.019 is very close to 1.02, so we'll just get any, yeah, 1.02. So we have that adjusted, so we know we have 100 milliamps. Let's have a look now at the other adjuster. So this should balance the operational amplifier, which is a 10 times amplifier. Does it have any effect? Not really, so there's definitely some problem around here. It could be, no, I'll put the leads together first, then let's try it. Let's see if it has any effect now. No, it doesn't have any effect, so there may be some problem around this part of the circuit. I mean, first of all, we need to balance these resistors. The instructions tell us to do that, so let's take the resistors out and get some balanced ones, and then we can try again with the adjustment to see if it actually does anything. Here are the resistors. I've unsoldered them. I'll use this meter because it has an extra decimal point on the resistance range, so hopefully it will give us the best reading. So this is one of the 10k, and it's actually reading, that's actually reading very, very close to 10k, I have to say. 9.999. What's this one reading? 0.982, so they're nowhere near balanced. But one of the two is very, very close. So I'll see if I can find another one that matches this. Let's look at the 100k, see how good these are. Yeah, 98.8, so that's not particularly close. Yeah, so they're not particularly close. So let me have a look at what I can find and I'll report back. I had about 10 or 15 of these, however many there are in there, and I found 2 of them which are pretty close. They're not exact. This one is reading 10.04. And this is reading the same, basically. So those are reading the same. Okay, I have 2 that read the same. They're not exactly 100, 100.2 on that one, and this one. Just make sure I don't touch it with my fingers. About the same, 100.4, 100.3. So those 2 are reading very, very similar. So we'll try these initially and let's see if it works better now, or if it actually works something like properly. Okay, I've changed those. It's still reading the same. It's still changing when I connect the leads together. Let's see if the little potentiometer now makes any difference to the reading. No, it doesn't. It's not working for some reason. I'm wondering if there's a problem with this op amp chip. I mean, I can try another one of the same. And also, I think the guy mentioned in his video you could try LM358. I think I also have some, to see if they work, but he mentions you may have some problem with them. I think it might be that this requires the correct op amps, something to do with the low offset he was mentioning. But I'm not an expert on op amp circuits. I've got an idea how to fix them, but I'm not an expert on them. Let's try another op amp in there. So this one's behaving basically the same as the other one, which makes me suspect there isn't actually anything wrong with it, or they just don't like working in this circuit, and the adjuster doesn't seem to have any difference. If it's reading 10.9 volts, you'd expect to find 1.09 volts between the input pins, which are 2 and 3, I think. Let's have a look to see what we have on the input for our op amp. Let's see what voltage we can see around it. I have the meter on volts. I've connected it to ground, so I can take the measurements with reference to ground. The two test probes are not connected together at the moment. So let's have a look at our op amp. So this is one of the inputs. This has got 1.22, and this has got 7 volts. There's a big difference between the two, 1.227, and then the output I think is on pin 6, which is 11.29, which is what that's reading. So that's what you'd expect with the two being open, that there'll be a big voltage difference. Let's connect the two together. So this goes down to 10.9. So on pin 2 we now have 2.1, and we have 0.9. So 0.9, 2.1. We have about 1.2 volts difference, and this is reading 10.9. Pin 6 will be the same. That's where it's coming from. So I think our op amp is working. It's just not seeing the same voltage on the input. So let's have a quick look at the schematic. When the probes are connected together, these 2 points, pins 1 and 2, are shorted to each other. So there should be basically 0 volts here, or very close to 0 volts. The Zener diodes, which are connected to each of the inputs and effectively connect to ground here, this is to protect against over voltage coming on the sense inputs. If there's more than, well, it's a 12 volt Zener plus 0.6 volts for drop there. So if there's more than 12.6 volts coming in here, it just grounds it basically. That's a protection device. So for the point of view of the DC voltages, we can ignore it. We haven't got more than 12.6 volts coming in. So what we have is 2 resistors coming into the inputs on the op amp on pins 2 and 3. And then we effectively have a voltage divider. So you can see this is 10k and this is 100k. So the ratio is effectively 10 to 1. And that acts as a voltage divider. This goes to ground. And we have basically the same on the other input. The difference being this goes to the output of the op amp. And this forms a feedback circuit. It basically sets the gain of the op amp if you go and look into some op amp theory. So it's these resistors that set the gain of the op amp to be times 10, which is basically what it's doing. It's giving us roughly 10 volts out on the meter, 10 or 11 volts, and about 1.2 volt difference on the input. So it's kind of working at a times 10. This is having no effect. Okay, so the first thing I'm interested to know is why we have a voltage between pins 2 and 3 when these leads are shorted together, and we should have no voltage there. This going to ground and this going to the output. So yes, some positive voltage coming here, but because of the voltage divider, we shouldn't see much voltage there. So what I'm interested to see is why we have a voltage between here and here. The whole idea of this is when there's no voltage difference here, there should be no voltage difference here. I think it's something to do with the op amp. In fact, I've got a good idea what is wrong with it now. But let's make some voltages and let's see if we can prove what the problem is. Okay, I'll switch it on again. I have a slightly dodgy connection on the positive power lead. There we go. So it's on and the meter's lit up. Yeah, it's working. Let's have a look now at the voltage effectively on the sense input. This is the voltage across that resistor we were looking at. We can go the correct way round. So cross sense we have about 8 volts because these are open circuit. Yeah. Now let's touch the two probes together. This goes down to 10.9. And we now have 0.002, basically 0 volts there. But if you look across the op amp input, we have about 1.1 volts, and this is what's wrong with it basically. And that 1.1 effectively is coming back through the op amp through the 100k resistor that goes from the output back to the input. And we can prove that. We'll just switch the power supply off, yeah? And we'll remove this op amp. And we'll switch it back on again. Now you'll see the meter is at a much lower reading. It's kind of floating around now, I think. We can look at our op amp now. Again, I've got the probes separated now. It's reading 0, yeah? Okay. Look at our op amp now, pins 2 and 3. And we basically have 7 volts. Let me just put this, make sure I get a good connection between these two. 7 volts. Let's go across the input. 8 volts. Are these connected together? They mustn't be. Try again. Input 0 as near as damn it. 2 and 3. 0 as near as damn it. So we can see that actual voltage is effectively coming back through the op amp. And I was just checking on the data sheet. I mean, originally it said this is a compatible for the OP07, but I'm pretty confident now it isn't. Let me show you the data sheet for the two. If we look at the data sheet for the OP07, you'll see that we have these pins 1 and pin 8, which is this VOS, it looks like trim, VDS trim, these two pins. And this basically is for setting the output, I believe, for balancing it. It mentions here very low input offset voltage obtained by trimming at the wafer stage. Low offset voltages generally eliminate the need for external nulling. It goes on to say it's very high gain, and it mentions down here that it's very suited for instrumentation and military applications. So that's the op amp the guy was originally using in his design, and according to the data sheet out originally, it said that the 741 is a compatible, but you see it isn't. If you look at pins 1 and 8, pin 8 has no connection, yeah? It doesn't have the same balancing effect. So this is why our potentiometer is not altering the output, is not balancing it like it should do. So we effectively set it to read 0 on 0 ohms. It's because the part we've used, or rather I've used, based on what I read on the internet, is not compatible with this circuit. It may well work in other cases, but it doesn't work in this case. So guys, this actually is a really good example of why when I was young. And I suspect a lot of you guys do this, and you may not be so young either, but you probably still do it, and I still do it, is build the electronic kits when sometimes I haven't actually got all the right components, and I'd go online, or back in the day I would look in a book and think, oh yeah, well look, you know, a single op amp 741, that'll do, rather than the bloody blah one I haven't got, yeah. And it doesn't. Or in this case, actually, there's two of them, yeah, and this one, which is the constant current generator, actually works, and it does exactly what it says on the tin, yeah. All 8 legs of it with 2 not connected, and it works, yeah. But this one, because it uses the other features of the fancy schmancy OP07 Op Amp, yeah, which is no more expensive than the 741, I just haven't got any. Yeah, because it uses that feature, this doesn't work, and then we have to troubleshoot our own project. But troubleshooting your own projects is a good way, A, of learning to fault find, and B, to actually build yourself some useful bits of kit at the same time. So I don't class this video as a disaster. I'm waiting for the OP07s to turn up. I'm sure they will. And then I'm sure this will work, and there'll be a part 2 because we're going to build some more projects. So this will come back with the OP07s and we'll see if it works. Yeah, it's a nice bit of kit really. The precision of this depends on these 4 resistors, the 10k and the 100k. Now the ones I have with a 4-band colour, I'm pretty sure with brown as the last band that's kind of separated a little bit further away from the others. I'll show you what I mean. Here we have the 4-band colour code. You'll notice on the 4-band colour code there's 5 bands. Yeah, yeah. And you'll notice on the 3-band colour code there's 4 bands. Well, the extra band is actually the tolerance. I think the gold on these is 5%. We can look it up. But these 4 bands are actually 1%. So let's look at them. We have brown, black, black, red, brown. So starting from here, brown is 1, black is 0, and black is 0. So that's 1, 0, 0. And then the next is a multiplier, which is red, which means 2 zeros. So these are 10k resistors. 1, 0, 0, and 2 more zeros is 10,000. The final code, the 5th band of the 4-band colour code, is the tolerance, and brown I'm pretty sure is 1%, and we can look that up. These ones are the 100k, so very similar. Brown, which is 1, black, black, which is 0, 0, and orange, which is 3 zeros. So that's 1, 0, 0, 0, 0, 0, and that's 100k. And then again we have brown in the last band, which is 1%. We'll just double check this just to make sure I'm right, but I'm pretty sure I am. So we can see it. The 3-band, as I call them, which are now called 4-band, but they weren't because we were always called 3-band back in the day. Like the 2.2Ks, we had red, 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 gold. So red means 2, red means 2. The third red is actually the multiplier, which is 2 zeros. All times 100 if you like, so that's 2200, 2.2k, and you'll see the final band gold is 5% tolerance. And also on power resistors you might see J, which is the same thing, 5% tolerance. So those 2.2k resistors are 2200 plus or minus 5%, and 5% is like 110 ohms, so there's quite a range of resistors that can be with that marking on. The 4-band, which they've now decided to call 5-band, but they never used to do, these were the ones we're looking at. So they were on the 10k were brown, black, black, yeah. So 1, 0, 0, and then red, which is 2 zeros, and then the last band was brown, and you'll see brown is actually a 1% tolerance. So those are the closest tolerance. You can get 0.5% tolerance. In fact, you can get less in special resistors. You can get lower tolerances. Ours are 1% tolerance, and that effectively sets the tolerance of this meter. But because you can effectively have, one set of resistors out 1% in one direction, and the other one's 1% in the other direction. So you might find some resistors are 1% higher than the stated value, and others in the circuit 1% lower. You might find 2% is more like the tolerance. To fix that, we could either order some very close tolerance resistors, if we can find them, or, as I mentioned, we can find a resistor that's a bit lower than we want, say 100k that reads 99.5, and then take a 470 ohm resistor and put it in series with it. And although the 47 ohm resistor will also have a tolerance, it's like 1% of a lower value, so it's going to be closer to its stated value. And by putting 2 or even 3 resistors in series, you can put a 100k, a 470 ohm, and if it's now reading like 99.97 or 98, you could then find like 180 ohm or 220 ohm resistor and effectively make up 3 by selecting the resistors. I would probably do it that way because I don't have the close tolerance resistors, but whatever you guys think, get into the comments below. Yeah. So we can see how the accuracy of this is set. We found 2 other ways to improve it, with close tolerance resistors or by some shenanigans putting resistors in series to get to the value we want as close as we can. I guess you could use a very close tolerance trimmer pot, a multi-turn one maybe. So yeah, there's probably a number of ways we could go at that. Obviously we need to change this for the right thing, and I think that's as much as we can do today. So I'm not going to call this a failure. I'm going to call this a typical self-built project on what goes wrong when you don't quite do it right because you think you know better. And I'm just interested to know what you guys think about it. So get into the comments below. Let me know if you enjoyed that. I'm sure we can do a bit more fault finding on projects as we build them and find they don't work as planned. Yeah. And just finally, I'd like to say thank you again to PCBWay for sponsoring this video. They make some really nice PCBs. You can see in the original video the guy had them in white. You can have them whatever colour you want. You can have your logo on, however you want to make them. So thanks PCBWay for the chance we have to build some of these projects and how projects you're sponsoring. And to everyone else, I'd just like to say I'll see you all soon on another Learning Electronics Repair video. Ciao for now, guys.